This is the Getting Ready lesson for Chapter 3, which is about geometric properties. And some things that we'll be doing throughout this unit is determining, through investigation, some characteristics and properties of geometric figures. We will be using algebraic techniques and analytic geometry to verify some characteristics of geometric figures. And we'll be using multi-step strategies to solve and verify geometric properties. So many of the skills that we learned in the last unit will come into play here again, and so a brief review of those skills and those formulas are coming up next. Two of the things that we used fairly extensively were the formula for the midpoint of a line segment and the formula for the length of a line segment. We'll need to be able to do both of those things in order to be successful in Unit 3. So I'm just going to show the general statement, and then we'll use the points A and B as a quick example of how to do this again. So we remember that the midpoint of a line segment is denoted x, y, where it's going to be right in the middle of a line segment. So let's say this is our line segment, and we're looking for this point M right here. Okay, so given the points A and B, or just the general statement first, we have the mean of our x values and the mean of our y values, and that will give us the coordinates of the midpoint. Using the example points B and A here, we can use the x values from both of these points and the y values from both of these points. -3 plus 4 over 2. And we simplify this, we have -2 plus 4, that's 2 over 2, and -3 plus 4, that is 1 over 2, which tells us that the midpoint of the line segment AB is found at the point 1 1/2 on the coordinate plane. Looking at the formula for the length of the line segment, we have that distance, D, equals the square root of the change in x, that's x2 minus x1 squared, plus the change in y, that's y2 minus y1 squared. And this was derived from the Pythagorean theorem. Now subbing in the points A and B as an example, we have our x values. Our x2 will be from point B, so we have 4 minus -2 squared, plus 4 minus -3 squared. You can simplify what's inside each bracket here. 4 minus -2, that's 6, still squared, plus 4 minus -3, that is 7 squared. Square my values inside the bracket. I get 36 plus 49. Now if we add up our values inside the radical, 36 plus 49 is 85. And that is the final answer. In exact terms, that is the length of the line segment from A to B with its midpoint at the point 1 1/2. The next skill that you will have to be fairly familiar with is how to find the intersection of lines. So in order to do this, you need to remember that lines go on forever. That's what these arrows at the end signify. These lines will go on forever. And if two lines do not have the exact same slope, then somewhere, some way, they will intersect. They will cross over each other. And this is called the point of intersection. It can also be denoted as xy, a place on the coordinate plane where these two lines intersect. And what we know about that location is that the x and y that they meet at will satisfy the equation of the first line and the second line, which means that the x from line 1 is equal to the x from line 2 where they meet. And we use that information to help us solve these problems, either by substitution or by elimination. We're going to take one example here and find the intersection of two lines. The first line that we are given is the line y equals negative 2x plus 12. We notice that this line is already in y-intercept slope form, slope y-intercept form. We have the slope here, and we have the y-intercept here, and we know that in our next equation, if it's not as pretty, we can just substitute y in. The equation of the second line is 2x minus 3y equals 12. Now this is not in standard form, but it's pretty close. And I could take a couple of approaches. I could rearrange the equations so that I can use elimination to eliminate a variable, or I could simply say, okay, I have equation 2 here. I know what y equals, and at the point where they intersect, the y from equation 1 must be the exact same y as the y from equation 2. So I can just sub in the information I know from equation 1 into equation 2. So I'm going to rewrite equation 2, but where I see a y, I'm going to substitute that y equals negative 2x plus 12. Still using all the other information from equation 2, 2x minus 3y equals 12. And now I can go ahead and use my algebra skills to simplify this. Okay, now I have to distribute this negative 3 to both terms inside the binomial. So negative 3 times negative 2x is positive 6x. Negative 3 times positive 12 is negative 36. That equals 12. Now I'm left with just one variable, right? I have just x's. I simply need to group my x's. And my other numbers I can move to the other side here by adding 36 to both sides. To get a single x by itself, I divide both sides by 8. I'm left with x equals 6. Now I know that at the point of intersection, the x value of the coordinate, the x coordinate is 6. I'm still trying to find that y. In order to find the y, I can sub my value for x into either equation 1 or equation 2. In this case, equation 1 looks a little easier. It's already in terms of y equals, so I will sub it in there. Y equals negative 2, and now wherever I see an x, I'm going to sub in the number 6 and keep the information of plus 12. Negative 2 times 6 is negative 12 plus 12. Well, here y equals 0. So I know that the point of intersection of these two lines is 6, 0. All right, the next thing we need to be familiar with is how to determine the angles inside a triangle. So we need to know that the sum of the angles inside a triangle is 180 degrees. The word sum means the answer to an addition problem, right? We have an addend plus another addend equals the sum, okay? And the angles in a triangle, that means the same as if we were to say the interior angles of the triangle. The sum of the angles in a triangle is always 180 degrees. So if we had triangle ABC here, we know that triangle A, angle A, measure of angle A, plus the measure of angle B, plus the measure of angle C is going to equal 180 degrees. And what we're missing here is the information for angle C. So all I need to do is sub in what I do know, and I can even rearrange this. I know then that angle C, which I need to find out, is going to be equal to 180 degrees minus the measure of angle A minus the measure of angle B. I can sub in the information that I've been given in the diagram. Angle A equals 40 degrees, angle B equals 65 degrees, and I can use mental math or put it in my calculator, and I will come out with angle C having a measure of 75 degrees. Pretty straightforward. All right, the last thing to get familiar with before we dive into Unit 3 is the types of quadrilaterals. Now, quadrilaterals are classified by the properties of their sides and angles. That means when we want to describe a quadrilateral, we need to talk about its sides and angles. First of all, the word quadrilateral. Well, if you broke it into 2 points, you would have the base word quad and lateral. Lateral means line. Quad means 4. So this is any figure that has 4 lines or 4 sides. Some of the examples we have drawn below here is a square, a rectangle, and a parallelogram. And we're just going to quickly analyze the key properties of these 3 quadrilaterals and then another set of 3 quadrilaterals. So first, the square. Well, what can we say about the angles in a square? A square has 4 equal sides. And 4 right angles. So now we've defined a square as a special kind of quadrilateral that has 4 equal sides, and we can denote them by our equal length signs, and 4 right angles, which we can show by doing our little squares in the corner. So what could we say about a rectangle? Well, a rectangle also has 4 right angles, but a rectangle does not have 4 equal sides. It has opposite sides that are equal in length. A rectangle has opposite sides that are equal in length, and it has 4 right angles. Okay, let's look down at this shape. Does anyone know what this shape is called? Now I know it's a quadrilateral because it has 4 lines, but it also has 2 pairs of parallel lines. This is called a parallelogram. Parallelogram. And a parallelogram is characterized by 2 pairs of parallel lines and opposite angles that are equal, and also the opposite sides are equal in length. And so to define a characteristic using a diagram, a parallelogram, we would note that these 2 lines are parallel and these opposite sides are parallel. I need a different sign for each because they are not parallel with each other, obviously. And they have opposite sides with the same length. It also has opposite angles that are equivalent. And so we can mark our angles by specific characters. We could use X's and O's to mark them, whatever the case may be. So that defines the parallelogram by its characteristics and properties.